Thanks, Dennis. Appreciate the chance to share a little bit of some of the information following up on Jerry's great discussion as well. So I think I don't really have any major arguments, so we're not going to have any kind of duking it out thing, because I think we pretty much are on the same page. But I think some of the information I have will also dovetail with some of the questions we heard after Jerry's presentation as well. So if you're curious why someone from a School of Medicine would be presenting on this topic, I was for many years at the Lighting Research Center at Rensselaer Polytechnic Institute, RPI, in Troy, New York. And recently, in the past few years, many of us have moved over to the medical school at Mount Sinai. Our director took a job there and brought many of us along with her. And as Dennis mentioned, I'm part of the Department of Population Health, Science, and Policy, which is dealing with public health. And obviously, fewer crashes on the road is good for public health. So that's kind of where my angle comes from. I know very little about medicine and that sort of stuff, which is obviously a lot of what goes on at Mount Sinai. So we're in Albany, New York. We were able to open a laboratory there since that's where most of us were located, rather than being in the city. Our webpage is here if you're interested in checking out some of the stuff we're doing in areas of like circadian rhythms and other stuff like that as well. I work a lot in the transportation lighting program that we have, dealing with vehicle lighting, headlights, headlight glare, that type of issues, as well as roadway lighting for pedestrians as well as drivers, signs and signals, and of course that includes the flashing lights that are on many of our maintenance and emergency types of vehicles. So my presentation had this acronym AIM, or AIM, and this actually is very similar to the objectives that Jerry mentioned earlier this morning about what these lights are supposed to be doing for us. What are their aims or objectives? So if you take nothing else away from this presentation, I hope this is one of the things you'll remember when we talk about this. A, for alerting, right? And that's probably the thing we think of most often for what flashing lights are doing. They're getting our attention. That flashing light in our visual periphery really is designed to get our attention. We notice those flashing lights and we immediately look at what's going on. Something's out there. What we don't often think of as much, but that's beginning to change, are these other two functions: informing, helping us understand what it is that we're approaching, and certainly making sure that the lights are not taking away from that ability to see who is on the scene, what is on the scene, what type of scene is it? Is it an emergency? Is it a work zone? Is it some other kind of roadside incident? And then manage. This is the idea that these lights should help us basically, do we need to slow down and stop? Should we shift over a lane? What are the types of behaviors that drivers need to do to safely get through and past that work zone or incident scene? I apologize for the blanking out here. I'm not sure what's happening. Maybe there's a bad connection or something, but I don't want to touch it too much. So what is the situation that we're trying to fix in that sense? What could be made better? Well, this is, again, a prototypical type of situation occurring at night where you might have something like downed a tree or power lines or some other issue on the road. A number of vehicles will pull up to that scene with their flashing lights on. They might be very bright, even though it's nighttime. You have this random flashing pattern, and that can be a little bit confusing about what a driver is supposed to do as they're approaching this, and it can also make it difficult for them to see the worker, the person standing between those two leftmost vehicles through the glare of those lights. So this is sort of a prototypical sense of the type of situation that we would like to improve using lighting. And I'll be kind of walking through some of the different properties of warning lights that make a difference at helping make that visual chaos a little bit less chaotic. Obviously, the intensity of the light is one of the most important factors, and we heard about the standards from the SAE, the different standards for warning lights. Also for fire and ambulance vehicles, for example, there are standards from the NFPA, the Fire Protection Association. All of these standards are minimum intensity levels at present. So the idea is you want to make sure that these lights can be bright enough, are able to produce intensities bright enough so that they can be seen in the bright daytime on a sunny day, right? That's sort of a worst case scenario when it comes to being able to see these lights or detect them at all. Does that mean that they always have to produce those very high intensities, even though they're capable of doing that? Well, certainly at night, we've heard earlier this morning, and we'll hear again today, that may not always be the best situation. Just brighter is not necessarily always better. So I'm going to talk a little bit about a field study that we did looking at nighttime visibility of people's ability to see a worker standing next to their vehicle. So you see this truck with those two, we modified these barricade lights to be able to produce different intensity levels, different flash patterns, and so on. And we had those lights flashing on the truck, and you could see the silhouette of a worker with or without a safety vest, a reflective safety vest, standing next to that vehicle. So we did a study where we adjusted the intensity of those flashing lights, the peak intensities, and we had drivers coming around a test track. This was done in conjunction with Penn State University at their test track, and people had to determine when they could see that there was or was not a pedestrian or a worker standing next to that light under different brightness levels and flash rates and so on. And again, with and without that safety vest as well. So we were able to record those detection distances. And what we found along the horizontal axis on this chart, and I know it's hard to see if you're sitting in the back, the lights get brighter as you go from left to right. And then the vertical axis is the distance at which people could see that there was a worker there. And that line way up at the top, that flat line is showing us that drivers could see this worker when they were wearing a reflective vest from at least 800 feet away. Even at the highest intensity level, a peak intensity of 700 candelas per light for these two flashing lights. The middle bar is showing much shorter detection distances for the worker that was not wearing the safety vest, and those are closer to 200 or 300 feet away. So much shorter distances when you're not wearing a reflective vest. And then finally, that bar at the bottom was when people did not see a pedestrian there, when there was no pedestrian, because we didn't want people just to say as they come around the corner, yeah, there's a pedestrian there, and let us know and have long distances no matter what there was, because we wanted to make sure they actually could see a worker standing next to the vehicle. And so they had to tell us also when there was no worker there, so they were very cautious and waited until they were just about a little more than 100 feet away. But that also made sure that we knew that they saw a worker present. Now these curves are all beginning to turn down when you get to peak intensities that are approaching 700 candelas per light. So that's telling us that that could be a problem at nighttime for visibility. We wouldn't expect that to be a problem for daytime. One of the other characteristics of lights is this idea of modulation. And what we mean by modulation is how much contrast is there between the high and the low level of a flashing light. Normally, most of the flashing lights that we might use are like the one on the left here on this slide. It just goes completely on to completely off, 100% modulation. The one in the middle is actually flashing at something like 50% modulation. So that light is always on, but it actually goes between 100 and 50% of its intensity. So it's a 50% modulation. And of course, when you have a steady light, there's no modulation at all. That's what we mean by 0% modulation. The reason that this can be important in the use of lights on our vehicles is that when you have high modulation, that actually makes it more difficult to do a task we call closure detection. When you're driving behind, and these are snow plows in upstate New York, where I'm from, with flashing lights with nearly 100% modulation and these steady burning light bars on the side of the vehicle. We measured how quickly people could begin to see that that snowplow was slowing down as they were approaching it without using its brake lights. And what we found is that people could detect that closure, that they were getting closer to the vehicle 2.5 seconds sooner than with the steady burning lights than they could with the modulating lights. So it helps reducing the modulation helps us get those cues that we're getting closer to a vehicle and helps us judge, how far away something might be. Having some percentage of the light that's always on helps us track that more clearly and better. So I'm returning back to this, again, this sort of scene of the visual chaos. What are we trying to improve here? And if we think about those two pieces of research and reduce the intensity of the lights and use less than 100% modulation so the lights are always on, we now have a scene that's a little bit less chaotic, a little easier to see that worker standing between those two leftmost trucks in this particular scene. So you can see that there are some things we can do just from a practical point of view to help improve things. What are some of the other things that matter? And this is where it gets a little bit tricky between what the standards tell us and what we have to do in a real-world situation. Most of the time, there are multiple vehicles at these locations. If it's an emergency, you don't even have time to really plan who's going to show up, where they're going to park, how you're going to arrange these vehicles and things like that. And as we heard, light-emitting diodes are very energy efficient, and it's possible to make those lights brighter and add more of them and not drain the electrical system of the vehicle as much. And so that, in some sense, has given us an opportunity to put more lights on. And in many ways, it helps us think that, well, if there's more lights, we're more visible and people will be able to see us better. And to some extent, that's true for alerting, maybe not so much for informing and managing. Most of the standards for these lights, again, are dealing with either a single light or a single vehicle, how much intensity per vehicle. But again, you often have multiple vehicles in some of these situations. We heard a lot about the random or asynchronous flashing, and that can still be somewhat confusing when you don't have a lot of information about, where do I need to go? Do I need to move over to the right, to the left? Should I stop? When you have a lot of flashing lights, there's not a lot of information there. It's just, hey, I'm here, we're out here. So we looked at synchronizing and sequencing flash patterns. You can see in the little video clip on the bottom here on this slide, this sequential array of lights that might be useful information to a driver to say, I need to move over perhaps to the left, if there's a lane closure, for example. So we wanted to see how drivers responded to these types of situations. This was a study that we did in cooperation actually with Sound Off Signal. This was done in their parking lot a couple years back. And we were looking at emergency vehicle lighting, which obviously is another type of situation where you use flashing warning lights of various types. And we have a multiple vehicle situation here, and you might be able to see at the top photo, the daytime photo, there's a silhouette of a police officer standing to the left of those vehicles. Well, in this particular study, one of the things we were looking at was synchronizing all of these lights so that they all flashed across the vehicles together, rather than having all the lights on all the vehicles kind of flashing in a very random pattern. And one of the things we looked at is as people looked up at this scene, we asked them to say, where is there a police officer in this scene? Is it to the left of the scene? Is it to the right? And we had these different combinations of lights. And we actually found that when the lights were flashing in a synchronized manner, and this is consistent with, again, with something we heard from Jerry earlier today, people could actually find that police officer more quickly. They could see where the person was, and obviously that's helpful information to a driver when they're trying to avoid a collision with the workers on those scenes. It was a little more than a second of additional response time that they would have. And obviously that translates to more distance that you have to begin to make evasive maneuvers and avoid a collision. We also looked at how drivers respond to these different types of configurations, both random flashing when you have multiple lights that are flashing with no particular sequence to them, versus synchronized lights that are all flashing on and off or high and low at the same time, or these sequential light patterns that might be giving you information about you want to move over to the right or to the left. We found, interestingly, in one study that drivers tended to slow down more in response to synchronized lights than they did to either random or sequential lights. In other words, it seemed like they judged that type of situation as something that maybe they should be prepared to stop if necessary. When all those lights were flashing on and off or high and low at the same time, it seemed to cause drivers to slow down, not a lot, only about a mile to a mile and a half an hour, miles per hour. So it's not a huge change, but again, this could make a difference when you're approaching a scene at a relatively high speed. We also found that when we asked people to judge how glaring or uncomfortable those lights made people, that even though all these lights had the same brightness and there was the same number of lights, essentially the same amount of photons coming into people's eyes, they judged the sequential lights as being less glaring, more comfortable. The higher bar means they're more comfortable. And what this tells us, and we've seen this in other studies when we looked at headlight glare, you could have the same headlight from a vehicle flashing their lights at you when you're driving home on your commute versus when you're driving in a very unfamiliar location and you don't know really where you're going. And that same light will be more uncomfortable when you're in a less familiar location. If your driving task is more difficult, the same amount of light can actually create more discomfort. So it does seem like having these sequential lights, which are giving you some information, they're helping me understand, oh, I maybe need to move over to the right or to the left. Having that information makes the driving task easier for the driver, and it can actually make the same lights less uncomfortable or less glaring. So again, I'm coming back to this prototypical scene of visual chaos. What is it we're trying to fix? We have high intensity lights in this nighttime scene, on-off flashing, a random flash pattern, very chaotic. Now we can actually look at not only reducing the intensity and the modulation, but using a sequential pattern. And it's possible to do this in a fairly straightforward manner from a technology point of view with GPS. You have timing signals and you have location. And the resolution is reasonably good enough that you can actually have vehicles coming in and out of these scenes, and these lights will begin to sync up with each other. So you don't always know where someone's going to park, especially in an emergency situation or a place where you have a washout or a fallen tree. You have to get there quickly. You don't have time to plan who's going to park where and exactly how their vehicles are going to be oriented. It's possible to have a system that creates this sequential lighting pattern to help people understand, oh, I need to move over perhaps to the left in this situation and reduce that visual chaos. Another thing that we heard about this morning is the flash rate. People do interpret faster flashing as being more urgent and certainly more attention-getting. But this is actually something we can take advantage of in some situations as well. Perhaps we found that we did a study where we actually had a scale model vehicle with different flash rates, and people had to predict whether that vehicle was going to move closer to them or farther away from them. We didn't tell them, well, if lights are flashing slowly, it's going to go in one direction. If lights are flashing quickly, it's going to go in another direction. They had no idea, but they would repeat this a few times, and we found that people were very good at learning once they had a consistent pattern. Oh, when it's flashing fast, it's going to be moving towards me. When it's flashing slow, it's going to be moving away from me. And they can distinguish that very easily. And that may be something that can be done in certain situations if you have a vehicle that's about to go in reverse, where the operator of that vehicle doesn't have a good line of sight around what's around them. Perhaps their lights could flash more quickly at that time while they're doing that. Or if you have a number of vehicles at a work zone and one of those is about to leave the work zone and enter the traffic stream, perhaps their lights could begin to flash more quickly while they're making that entry, and let other drivers know, that they have to be a little bit more careful around that vehicle. So those are possible applications for using the flash rate as a method of almost like communication. And again, even if drivers don't understand it the first time, the second time they see it, by the time they've seen this a few times, they will understand if it's done consistently. Probably the questions that we often hear about these lights most often are about the color, right? What color is most visible? What color is most glaring? What color should I use on this type of vehicle or that type of vehicle? And we have looked at that in a number of different ways. This was a study we did in cooperation with the Emergency Responder Safety Institute. And Waylon was kind enough to help provide some of the lights that we used of different colors. We had red, blue, white, and yellow lights. And we could basically adjust their intensities and have the different color patterns that people could approach in this field study that we did actually with Embry-Riddle University down in Florida. So the questions we're asking is, how does the color of a light affect the visibility of that light, how visible they appear? And how does the color affect their ratings of discomfort glare? You may have noticed, as we are using more and more LED headlights, that whiter or bluer color of headlights compared to the yellowish halogen lights sometimes makes those lights look awfully bright and sometimes even uncomfortable. We've seen a similar trend in studies like this. First, we're talking about the visibility of the lights. When we are matching these for intensity, red and blue lights tend to be judged as more visible. And this seems to be because they actually do look brighter for the same candle power. The more saturated color will appear brighter. And it seems to make those lights look more visible relative to, say, yellow and white lights. However, just because that light looks more visible or looks brighter, it actually doesn't necessarily mean that it's going to seem more uncomfortable or glaring. We found that it was blue and white lights that were the glariest for the same intensity compared to yellow and red lights. So that warm color seems to be more comfortable to our eyes at night, and the bluish color that is included in white as well as, of course, blue does seem to create more discomfort to our eyes. So it's an interesting dichotomy that a light that looks brighter isn't necessarily always going to be more uncomfortable to a driver. We also found that it was the intensity of the light rather than the color of the light that affected how visible the actual scene on the road looked. So in terms of another type of glare we call disability glare, how does the light actually reduce our visibility when we're driving at night? It seems like once you know the candle power, that's the primary factor. The color doesn't matter as much for reducing visibility, but does make a difference for that discomfort feeling that we feel. Another thing that we've looked at is not only the flashing lights themselves, but the presence of some steady illumination around the vehicles in an area where people are working. In all four of these video clips where you have bright flashing lights, there's a little scale model. These are scale model scenes. There's a little figure of a police officer standing next to their vehicle. You could probably only see that police officer in the two video clips on the right. And you'll notice that when those lights are off on the right, there's a little pool of white light around the vehicle. It's actually only a couple times brighter than a full moon. It's not a lot of light, but that goes a long way at making that person more visible as they're working and walking near their vehicles. That police officer is present in all four of these, but you just can't see them through the glare of the lights in the other two scenes. And so that's something to think about, that there's a need, even in obviously in work zones you have illumination for doing the work, but in some of these situations where people are coming up to a scene, if it's a downed tree or an accident scene, other types of responses that you might have to make that you don't have time to plan for, some way to get a little bit of steady burning light would be helpful at making workers more visible to approaching drivers. We also wanted to look at the impacts of vehicle markings, and we heard a little bit about this as well. And one of the things that is important is, just like the standards for flashing warning lights really are minimum standards. You can go above the minimum, and there's really no upper limits on those standards. For when there are standards for reflective markings, it's a similar situation. There's a minimum reflectivity level, but many agencies, and especially in the emergency response world, it may not be quite as true in the highway maintenance world, many times agencies will use much brighter materials than they need to or than they're required to, on the theory that, well, if I make it brighter and it's reflecting more light back to the driver, it's got to be better. Well, there was some study done 10 years ago or so on highway signs, and actually in some situations, brighter highway signs with higher reflectivity levels actually made it harder to see objects and pedestrians and animals along the road. So that light reflecting from your headlights off the sign and back into your eyes can sometimes make it difficult to see. In that study I mentioned earlier, we were looking at the color of the lights. Sometimes we had a reflective panel behind those lights. And what's interesting is that we found sometimes that presence of that reflective panel, and that was a high reflectivity level because this was in the context of fire trucks. If the reflectivity was too high, it actually made it harder. People couldn't see if there was a pedestrian or a worker in that scene until they were much closer. So that gave us a hint that there can be problems if these markings themselves are too bright. And so we followed that up just this past year and presented this at the TRB meeting in January, where we simulated a fire truck and a mannequin wearing a fire turnout gear with reflective bands on it, so they were wearing retroreflective gear, and people would look at this scene with different materials. We looked at both red and yellow combinations as well as blue and white. We looked at fully outlining the vehicle or covering the back of the vehicle, and then outlining just the edges of the vehicle. And we found that especially when it was the full vehicle that was covered in this high-intensity retroreflective marking, that it took longer for people to see where this firefighter was, whether they were standing to the left of their vehicle or to the right. And it did take about a half a second longer. Again, that sounds like a short amount of time, but when you're driving at 40 or 50 miles an hour, it can make a good number of feet of distance of extra stopping time. So there does seem to be some possible issues with having some of these materials be much brighter than they need to be. And possibly, we didn't see that as much with the outlined marking. So again, you can have the vehicle itself be a particular color, and maybe we don't have to cover the entire surface of the vehicle with retroreflective marking, but maybe some of the outlines would be more helpful. I also just want to talk a little bit about the coordination of the vehicle color and the color of the markings and the flashing lights. And these were some of the questions we heard earlier this morning. The vehicle colors themselves, obviously we know fire engines generally are red, and there has been some thought that, well, maybe lime green or yellow fire engines would be more visible. It makes a lighter colored vehicle at night. Interestingly, there was some movement in that direction, and now it seems to be swinging back where more and more fire departments are just going with red. More than 85% of the fire departments are using red fire engines, and that seems to be actually still increasing. And part of that reason is they want to use something that's familiar to people. They want people to know when they're approaching this red large vehicle that it's a fire situation, it's an emergency situation, and they may need to be careful as they're approaching it, as they're driving. And so we do have that association, especially with red. Red lights, red colors often are associated in people's minds as something that's an emergency or more dangerous. Now, the color schemes that we use on lights and markings are very different in different states. In some states, blue lights are for police. That's true now in New York State as well in the past 10 years or so. But also blue lights are used by volunteer firefighters in New York State. So you have different responses that you're supposed to give to these different kinds of vehicles, and you cross state lines and the color code changes again. And so that can be a challenge in terms of trying to communicate what it is that people are actually looking at. We've been doing a few studies trying to begin to understand this issue, and this was a pilot study where we had people looking at either red vehicles with red lights or yellow vehicles with yellow lights, and we sort of asked people which set of vehicles would you consider is more likely to be an emergency. And then if you look at these little charts on the side, the top chart, when you see a red box or a red piece when there's red in those boxes, that means people chose the red vehicle as the thing that was more likely to be an emergency. When you see a full yellow box, it means they said the yellow vehicles were more likely. And when you see a half red and half yellow box, that means they saw a combination of red and yellow vehicles as more likely to be an emergency than just a yellow vehicle. Not surprisingly, if you keep the colors of the lights and the vehicle the same, it reinforces what people think is an emergency. The red vehicles with red lights are almost always chosen as the emergency. When you flip that and put yellow lights on red vehicles or red lights on yellow vehicles, it becomes very hit or miss. The table in the middle is really showing you sometimes you see red boxes and sometimes you see yellow boxes. Sometimes people use the color of the vehicle and its markings as the primary cue. Sometimes they use the color of the lights, and it's not consistent. If we actually reinforce the color of the lights by not only using red lights on red vehicles, but make those lights brighter and flash faster to reinforce that sense of urgency or emergency, the table on the bottom where you see it's almost all, those cells almost have all red, it's much more unanimous at what people judge as more likely to be an emergency. So trying to follow up on some of this, we actually did a video survey looking at to get more people involved, and people had to make these different judgments, whether it was yellow vehicles with red or yellow lights or red vehicles with red or yellow lights, different flash patterns. And basically what we found when we asked people, again, which vehicle do you think is more likely to be an emergency situation, we found that it was probably the lights. 3/4 of the time, people would use the flashing light color as their primary cue. If it was, red lights on a yellow vehicle versus yellow lights on a red vehicle. It would be the red lights on a yellow vehicle. Those red lights were what 3/4 of the time people seem to judge as the emergency. Of course, if we coordinated those, we could get up to nearly 100%. And we could even improve it if we made the red lights brighter and flash faster relative to the yellow lights, which were a little dimmer and a little slower. But the primary cue, again, was the color of the lights. Now, we also wanted to look at, well, what happens when you have multiple vehicles in these situations? Red and yellow lights and red and yellow vehicles. And we did a study where we asked people to look at these different scenes, and sometimes there were multiple vehicles. Sometimes only one of the vehicles in that cluster might have their flashing lights on. Sometimes they would all have their flashing lights on. And we asked people, how likely would they be to slow down and prepare to stop at this situation or to proceed with caution? Kind of another way of asking, is this likely to be an emergency or a non-emergency? And what we found, as you'd expect, red lights on red vehicles were the most likely to be seen as an emergency. Yellow lights on yellow vehicles were the least likely. But we also found that if you had 3 vehicles in a scene and only one of those had their lights on, that was also sufficient, as likely to be judged as an emergency as having all the vehicles have their flashing lights on. And if you made that vehicle be the one that was closest to the traffic stream, that also increased the percentage of it being judged as an emergency. So this tells us that, if glare is an issue, and some of the work that we've seen says maybe sometimes there can be too many lights, especially at night, or they can be too bright. This tells us that there may be opportunities to not use all the vehicles with all their lights at all times, especially at night. That we can still convey a sense of this is an emergency by using, only some of the vehicles having their lights on. They don't all have to be on all the time. And we reinforced this. All those studies I've been talking about recently were more or less laboratory studies with scale models, but we did want to look at this at least on a full-scale test track situation. So to easily switch between red and yellow vehicles, we created this decoy that allows us to flip back and forth. It was actually strangely very realistic looking as people were driving. We had people asking, how did these new trucks get on the track and where did the other one go, and so on. We could basically flip one of the plywood surfaces down with this vinyl image of a vehicle and look at different patterns. And what we found is that we found very similar trends. When we had red vehicles with yellow lights or yellow vehicles with red lights, it was the vehicle with the red lights that seemed to be judged more likely to be the emergency. And of course, then once we added the coordination of the vehicle color and markings with the red lights, so if it's all red lights on a red vehicle with red markings, it basically was unanimous. That was the emergency situation. In the daytime, we found that, how certain they were about that was based on if it was coordinated. If you had red lights on a red vehicle or yellow lights on a yellow vehicle, people were pretty certain about whether they thought it was an emergency or not. When you had mixed colors, they were less certain. At night, however, their primary cue was the light color, and that their certainty or uncertainty didn't change. So just to bring this to a close, based on this type of research, some of the things that we found, and some of this is consistent with what we heard earlier as well. At nighttime, there may be opportunities to reduce the intensity. And some of the levels that we found of, say, 1,400 candelas per vehicle with 2 700 candela lights seems like a reasonable upper limit, and it's pretty close to the 1,200 candelas that Jerry found. So I think that's a pretty good agreement at saying for nighttime use, we may want to think about, is there a point at which we want to say the lights shouldn't be brighter than this on a particular vehicle? And that will allow us to inform and manage drivers. High-low flashing versus on-off flashing can have some advantages for judging how far away or how fast a vehicle might be moving. Synchronized lights and sequential lights can both reduce visual chaos, and of course, sequential lights can provide additional information about should I go to the right or to the left and so on, and make our driving task a little easier. When it comes to color, we've seen things like the blue and red lights are more visible, but it's actually blue and white lights that seem to be the more uncomfortable from a glare point of view. And something like just a little bit of steady illumination in the work site can make a big difference at making workers easier to see. Just like lights can sometimes perhaps be a little bit too bright, or sometimes even a lot too bright, reflective vehicle markings also can be sometimes too bright. We don't have to always use the most reflective, most highly reflective materials. And finally, again, we're just beginning to understand how people understand the colors of the vehicles and the lights and how that might mean this is an emergency versus this is a non-emergency. There's obviously a lot of state-by-state differences in what colors people use. So I won't say we understand this a lot, but there does seem to be some advantages of coordinating those colors, at least using consistent color schemes. And some of the guidelines Jerry presented earlier for different situations, whether it's the inspector versus the first responder vehicles that are coming out, in those different situations, having some consistency in what people see and how they can respond to it will actually be very helpful. So that's all I have. I just want to thank the organizers and the research sponsors of our work that we've done over the years. And I have a list of many people who were involved in helping us with this work. Too many to list out loud, but all of these studies were definitely team efforts. So I thank you for your attention, and to the extent there's time, I'm happy to take a couple questions.
Questions?
Shane Gilchrist, New York State DOT. I'm struggling with the analogy of the operator perceiving more or less of an emergency. I don't want to speak for everybody in the room, but as I sit here, I would argue that I want the operator to be equally concerned whether it's the state police or our guys in a work zone. And while I understand that state police have a different role and when they're out there and their vulnerability compared to our workforce that's out there, to be able to outfit a number of different vehicles with different configurations is probably not realistic because we can't afford the fleet that we have, let alone multiples of things for different situations. So I guess I'm not sure I understand how you approach this from the standpoint of the operator's perceived emergency. I want them to perceive that there's something there that they should slow down and be careful, period. So just my thought.
Yeah, I don't disagree with that. I mean, the idea here is that I think there is some advantage to giving people information about the type of scene they're coming up against, whether it's something that's more designed because it's a work zone that was planned well in advance versus a situation where people are responding minutes ahead of time because something happened. And all these different situations, that's the primary issue. I definitely agree that we're not trying to convey the sense of, well, if it's an emergency and there are emergency responders there, that we want to be more careful of those workers than of the workers who are, fixing the road or doing other work, because both of those are very important. It's really about the information that they need to safely get past that scene or stop and try to get past it. That's the type of information that's most important. So in these studies, we were using that emergency or non-emergency as just a way, can they differentiate between these different situations? But it's not necessarily to imply that one is more important than the other, because that's definitely not, I don't think that's what we want to convey, for sure.
I guess on top of that, so the colors that were perceived as more of an emergency, was it because they were perceived as law enforcement, or was it because of the colors themselves?
It's probably a little bit of both.
Yeah.
Probably the law enforcement piece, because we traditionally will use those colors, red and blue, rather than yellow.
Yeah.
Whether was designed that way or just kind of worked out that way, I don't know.
Yeah. I guess, and the other question I have is about the glare or the uncomfortable colors, the white and the blue, and if that uncomfortableness or that glare increases confusion, and if there's a negative, I assume that's a negative thing, if it's more comfortable, maybe there's more of an ability to recognize I didn't know if that was something that you concluded as well.
It wasn't directly in that study, but we've done other studies looking at headlight glare, and we found that when people are uncomfortable, they spend more time with their heads looking somewhere not at the road.
Yeah.
And we believe that's not a good thing. But it is one of those things where just being uncomfortable, maybe that means you slow down, and maybe that's a good thing. But if they can't see, or they feel like they can't see, and they're trying to look somewhere else just to reduce that discomfort, we probably think that's not helpful.
Since you are so close to some medical personnel at Mount Sinai, can you find out if there is any medical reason for people to drive into the lights, be it when they're non-inebriated or impaired some other way? And then that would be very helpful
Yeah.
and enlightening for us all.
Yeah, we have asked about that, and actually in some of our studies we tried to look at it, and what we would find is on average there'd be like no effect. People would not drive any closer or farther away, but we did find certain people, certain individuals were the ones that tended to be the ones that tended to go a little closer to the lights, and other people would actually try to avoid them, or seemed like they were trying to avoid them. They would consistently drive farther away. So there may be individual differences. Certainly there are differences in people's sensitivity to flashing lights. We've gotten many calls about people who feel that they just can't function at all in an environment where there's flashing lights. So I think there probably are some individual sensitivities, but there's a lot of unknowns about, we've been asking about this, is there something you could predict, give someone a test and say they're going to be more or less sensitive to this? Because different individuals respond differently, and that makes it hard from a research point of view. On average, there's no effect, but half the people are going one way and half the people are going the other way. And we don't know how much of that might be physiological or psychological. I mean, there's different reasons they might do that, based on what they perceive to be safer or better, or they might not even be thinking about it at all. It might just be something they do without really thinking about it. So yeah, it's a very open question, and we don't know yet.
We have time for maybe 2, 3 more questions. Going once, twice, 3 times, okay. Thank you, John.